Good morning, my dear children. Okay, today I wanna start the topic about carbon and its compounds I have discussed during the introduction, and now I'm going to say whole the chapter synthesis. And guys, I wanna say for you synapse of this chapter. It's mean the main points and main. If you can read this video, if you see this video once, you can write the whole exam of the carbon and its compounds with get the full marks. So I'm sure about it. Please subscribe my chemistry life channel. Okay, let us start. The today topic is the carbon and its compounds. So carbon belongs to 4a group. Carbon belongs to 4a group, so its valency is 4. And carbon is a non-metal, you know about it very clearly. Carbon is a non-metal, and carbon configuration in ground state 1s2 2s2 2p2, and if it gain 4 electrons then it become imbalance because there 4 protons in the nucleus cannot balance 10 electrons. And guys, if carbon can gain 4 more electrons, it will go to the next group. If it will lose -4, it will go to the before group because it is unbalanced. So when it is there, when it is stable with the 4 valency, so then only it can be very good, है ना? So and its electronegativity is 2.5, and it is also not possible to be lost 4 electrons because while losing it needs more energy. For losing or for gaining, it need more energy. In our earth there is much energy, means that much of energy to differ the atomic structures and atomic valencies. No more energy was found now, so it may collapse the whole world, I think so. Yeah, carbon can wholly form covalent bond and it is tetravalency. So its covalent bond, it's means sharing, है ना? It can bond C-4. It is called as carbide and it is tetravalency. Tetra क्या है? 4. Four or more than the electrons were present are called the tetravalency. And guys, carbon can make single bond with same elements, single bond with different elements. To form the same bond as the single element or the double bond or the triple bond, the carbon is in the first place, है ना guys? So I think so you have grasping the concept very easily, है ना? Please like to my video. One double bond and two single bonds. One double bond, two single bonds. One triple bond, one single bond. One triple bond, one single bond. Two double bonds. Electronic configuration of the carbon is 1s2 2s2 2p2 or 1s2 2s2 2p x1 2p y1 2p z0. And guys, this is the excited state and this is the ground state which is represented by these arrows. It means that it completed the one shell and it going to the next. It's going to the Pauli's exclusive principle that the any electron goes under and one after pairing all, then next one electron will pair the other one. So this is the Pauli's exclusion principle. This is also going in this ground state. And next, this is excited state. In excited state, this is the structure. And next, normally carbon is the ground state. While it needs to make bonds, then it took bond energy from other elements and then it goes to the excited state. And guys, so it need to be understand. If you understand anything, please comment me. Okay. Orbital hybridization was introducible in Pauling. So I think so it can see in the SSC book. It is very simple to see this. Linus Pauling or just search in Google. And next, permission. Permission क्या है? The permission is not in the business. In the chemistry, permission is nothing but when bonds are formed, energy is released and the system become more stable. So it means that when bond was happening, so this bond was very stronger, है ना? So when it's stronger, it will be stable. It will be stable. So please think chemistry as a chemistry, not as like the maths or physics. So like this all subject, chemistry is a very unique subject that we can understand in a very clear way, like in chemistry way. And guys, methane CH2 CH2 C2H4. So we can call a CH2 CH2 as the C2H4. See here, 2 C's, 4 H's, C2H4. So it's valid answer. And next, going to the next one. It's my personal book now, guys. Just please subscribe to my channel. I'll come with very interesting topics like this more and more. And guys, yeah, let's start the class. In this, the angle is 109 degrees 28 methane. Methane methane का formula guys, methane का formula CH4, sorry Nana, CH3. Okay, and it forms in tetrahedron. Okay, it's mean 4. Ethane, the angle is 120, and lactylene C2H2. Allotropes of carbon. Allotropes of carbon and means similar. Chemio, different, physio. Okay. So now let's see the property of an element. Ruko guys. The property of an element to exist in two or more physical forms having more or less similar chemical properties but different physical properties is called allotropy. So guys, once I'm repeating it, just be concentrate to listen and make understand your heart. The property of an element to exist in two or more physical forms having more or less similar chemical properties but different physical properties is called the allotropy. Allotropy is nothing but the chemical properties were same but the physical forms were different of same atom. I mean it belongs to the same category है ना. And next, the different forms of elements are called the allotropy. Allotropes form due to the difference in the arrangement of atoms in the molecule. Difference between the coal and the diamond. See, coal also um, ఏమంటారు, coal also prepared from carbon and diamond also just coming from the carbon. It's both the allotropies or the carbon. But what's the difference between this both? Coal is very black in color and no, it will produce just carbon monoxide, no use of it. Diamond gives us the white shiny and it is used in the wells, है ना. So you are giving the great preference to the diamond, but why? Both is uh, both is prepared by carbon, right? But why? So this is the big question mark. So I can answer this question in a very smart way. So carbon, both are just prepared from carbon, but the intermolecular forces and the attachments and the bonds are stronger in the diamond, and it become the more preference. And coal is very very gaffly. It means the intermolecular forces are more and attraction is low, and the bond was so weak. That's it. So it's my answer. Okay. Allotropes of carbon classified into two types. What is those? Amorphous, crystalline. Amorphous means coal, coke, wood, charcoal, animal, charcoal, etc. Crystalline, diamond, graphite, Buckminster fullerene. So like this. These are the some examples, na guys. So okay, I can tell you about the diamond. It is a three-dimensional 3D figure. We can see like so like this. So like this in 3D figure we can see it's fully shine. So in the physical total internal reflection we can know about it, how why diamond can shine because its refractive index is 24.2. It's very low, so that for the low angle of light only it will shine. So this is the property of the diamond. Okay, we should not go to the physical science now. It's chemistry. Yes, each carbon is in the tetrahedral environment. Yes, 4. And carbon makes sp3 hybridization. Next coming topic I can tell you hybridization. Diamond forms CC bonds. It's mean AN. It's a single bonds. By the cause of CC bond, it is very strong. Okay, CC bonds are so strong, na guys. So by the cause of CC bond, it is very strong. So to dissort it needs more energy. See, for diamond cutting, diamond only used. We should need to cut the diamond with the diamond. So this is one of the proverb too. You all know about it. వజ్రాన్ని వజ్రంతోనే కొయ్యాలి. So you know about this proverb, right? And guys, okay. So by this way, it's called the earth material. It doesn't conduct electricity. Oh no, it doesn't conduct electricity. So it didn't have that much of capability and the brilliance, and it's due to the total internal reflection. Graphite CC bond. It is weak interaction. It is a chain structure. So that pencil can erase using rubber. There is a weak interaction between the letters of pencil graphite and the paper. See, it's a chain structure. It will make bond with 3 carbons around it. This is when 3 carbons around it. And guys, it's two-dimensional sp2 hybridization. See, if it's 3D, it's gonna be going to the sp3. If it's 2, it's going to the sp2. So what's the mystery was going on here? Nothing else, guys. So if the dimensional structure is in how much dimensional, so it belongs to the hybridization. Hybridization is nothing but the atomic orbitals of the same element can give the same orbitals as like the with the same energy. So that's it, the hybridization. Distance between layer to the layer is 3.35. So in the graphite structures, this is the layer, this is the layer. So here 3.35. They have distance between it, not centimeters, not meters, not micrometers, it's picometers. And guys, so it's very low to see. Even in electron microscope only it is very difficult to see. And guys, so please subscribe to my channel and share this video to many members and make them view out. Next, the interaction between two layers are called the London dispersion forces. So it is used by lubricant is called the lead pencils. It will make weak interaction with paper. Okay, Buckminster Fullers. I showed this picture in the SSC textbook. It is available. So it is known as the 60. Elagana raskochu. C60 or 60C. Anything else you can. And next, it is in sphere. It is in sphere, ellipsoid, or tube depend on the these oriences. Yes. Fullerenes are formed when vaporized carbon contains in an atmosphere of an inert gas. Yes. When you see these fullerenes means vaporized carbon condense. Vaporized carbon. See, when carbon can heated, for every heating they will come vapor, right? So this vapor when reacts with the noble gas, and again the water droplets will come, means condensation process will going on. This condensed water we can see the fullerenes. And guys, see, it's very simple. And next, it is an exact spherical position, then it is called buckyball. It is exact in sphere shape. Sphere is not exactly circle, but it is an exact sphere. And fullerene 60C molecules continues 12 pentagonal and 20 hexagonal phases. So it is sp2 orbitals, it means it's 2D. And next, it is also used to remove resistant bacteria. It is also used in melanoma cancer. Very important. For competitive, for polytechnic, for everything, for every competitive exams also, it is very important. Melanoma cancer, and it will remove resistance bacteria. Means it is the advantages. And next, nanotubes. Nanotubes are very toughest typical topic of the chemists. Nanotubes, the structure is very typical. See, it is also another name of allotropic of carbon. Form of allotropic of carbon. So it is discovered by Sumio Zima in 1991. It is very important in the competitive exams. 1 mark we can gain in these both. So I am promising you that I am giving the 100% sure about in the examination point of view. These two questions may be confirmly any one question will come. It is in the hexagonal arrays of covalently bonded atom. So these are best electrical conductors. These are the electrical conductors. This has capacity to bear electricity. In integrated circuits, nanotubes are used instead of copper to connect the components together. So scientists has inserted biomolecules into nanotubes to inject them into a single cell. So that's it, guys. So many more are there. And next, Wenzel nature of carbon. So I'll close this session by the Wenzel nature of the carbon. Causes to form largest number of carbons to show catenation to form various types of bonds. Catenation क्या है? Carbon has ability to form longest chains containing millions of carbon atoms in molecules in the same proteins, and sulfur and phosphorus are also other examples. Catenation क्या है? To form longest chains containing millions of carbon atoms in molecules with the same proteins. It means that catenation means forming chains with the forming chains with the same category. Same category. So if you form like that, then it is the process is called the catenation. Okay guys, let me continue or may I can stop. Okay, let's see how much topic was there. Yeah, it's small topic only, so I'll explain all. Hydrocarbons. See Nana, hydrocarbons, the compound containing only carbon and hydrogen in their molecules are called hydrocarbons. The compound, hydrocarbons are the compound which consists of the hydrogen and carbon. It's very simple, right? Simple to remember. These are the two types: open chain hydrocarbon, closed chain hydrocarbon. Aliphatic, aromatic. Very important. Aliphatic, aliphatic, aromatic. Aromatic. Mate means something pair. It's mean closer. Close together. Mates are close together, right? So like aliphatic. If it's aromatic, it is closed. If it's aliphatic, it is open, right? So you can remember like that. And guys, I just told for you in chemistry way, but not in chemistry way. Alkanes. Hydrocarbons containing only single bonds between two carbons called as the alkanes, and double bond alkanes, one triple bond between alkynes. So I already discussed with you. So this general formula in saturated hydrocarbons. I already told for you, if single bond is there, it is called the saturated hydrocarbon. It is the substituents reactions. So in more and more videos, I can tell you the substitution reactions also by the end of the carbon and its compounds videos. I can tell you the part 4, and they are called paraffins due to less reactivity. They are called paraffins because they are less reactivity, because one bond क्या है, एनर्जी का लो, बॉन्ड का वीक. The triple bond है एनर्जी का हाई, है ना guys? So this is the general formula. This is unsaturated because double bond. Additional reaction, it is addition, right? Plus क्या है double, it's addition. Yeah. And next it's addition reaction. It is also because it's more addition, and it is triple bond unsaturated. Saturated hydrocarbons, the hydrocarbons containing only CC single bonds are known as saturated hydrocarbons. The hydrocarbons that contain at least one double bond is contain at least triple bond between two is called the unsaturated. Unsaturated का क्या है? Saturated single bond. Even it is one single bond, you can get the saturated. Even in the whole the equation, if one double bond or if one triple bond, it is gonna be to the unsaturated. And guys, yeah. And next, functional group in carbon compounds. The characteristic properties of an organic compound depend mainly on an atom or group of atom and its molecules is known as the functional group. Functional groups I already discussed in the before video of the table. I have shown you alcohol, aldehyde, ketone, ester, xanthine. I have discussed you a lot about it. So like that, the characteristic properties of an organic compound. Organic compound, it's naturally occurred. Depend mainly on as atom. In any chemistry, that's depend upon the atom, because it's the structural and functional unit of the molecule. Our group of atoms. Yes, it means the molecule, and it is molecule is known as the functional group. That's it. The characteristic and the properties of the organic compound just depend on the atom and the atomic molecule. That's it. And next, coming to the carbon compounds with CH(X). X represents the halogens. See alcohols. Before I have discussed about the functional groups, right? So that one only. ROH are alcohols. R is alkaline group. So this one. It will form single bonds. So see here, this is the formula. Alkyl group or hydrogen. R1 carboxyl. Same. R COOH R alkyl group or H atom. It's mean the hydrogen. Is the COOH get replaced by R. Amines NH2 group, NH2 primary, NH secondary and tertiary. So how I am saying for you is, see guys, it's very simple. See, it is the in the next video, in the part 4, I'll explain you about the what is the preference of the functional group and how we can balance the carbon and its compounds equations. Okay guys, and next, coming to the next topic, functional group. Alcohol ROH, aldehyde RCHO, ketone RCOR, carboxyl RCOOH, ether ROR, ester RCOOR, amine RNH. Chemical properties of carbon compounds. Combustion, oxidation, addition, substitution. So next, combustion. The process of burning of carbon compound in energy of oxygen to give heat and light is called the combustion reaction. Combustion reaction is nothing but releases something. It's like heat, light, electricity, gas or something it will release by burning. It's called the combustion. It's very important, Nana. Not only in this, in your higher studies also it will very important. And while we will burn saturated carbons, it will blue color flame. Oh, oh. Okay. When the saturated carbons were burned, then it's blue in color. After, while we burn it, we can get yellow in color. Even saturated carbons also need sufficient O2. For burning anything, we need to do O2, right? So as like saturated carbons also need sufficient O2 for burning. And next topic, due to the coal petroleum, it causes pollution in environment. Yes, we know that when we burn coal or charcoal, it burns sometimes they flow grow red without flame. So it is very dangerous to the nature. And next, oxidation reaction. Every combustion reactions are called oxidation reaction because oxidation क्या है O2 है. Combustion क्या है O2 है because O2 never है combustion and the oxidation reaction को stop करेगा. So combustion का and the oxidation का O2 का very important है, बहुत अच्छा है. But all oxidation need not be a combustion है. Oxidation reaction not depend on the combustion depend on the oxidation. Oxidized agents or oxidants are substances that oxide other substances and they reduce themselves. Oxidized agents increase the H. है ना guys? अदे reduced agents can increase oxidation, है ना? Ethyl alcohol undergoes oxidation to form the product acetaldehyde and finally acetic acid. Acetic acid का formula CH3COOH. It is very weak acid, है ना? Isomerism, the phenomena of processing some molecular formula for different properties of the compounds, is known as the isomerism. Very important. And isomers also. Isomers is nothing but same molecular formula but different properties. అది అంటే neon తీసుకున్నాం, fluorine. These are the different, right? But coming to this weights ఇలా. So these are the some examples. Homologous series. Next, the series of carbon compound in which two successive compounds differ by CH2 units is called homologous series. So they have one general formula. So I have already discussed with you in a 3 times and again repeating that. Hey guys, not there here. No bother about it. Yeah. Successive compounds differ by CH2. They possess similar chemical properties due to the same functional group. An individual element in homologous series is called the homologous. Additional reaction. Only alkenes and alkenes only participate by this here in the place catalyst role. Substitution reaction क्या है? Addition reaction we have alkenes and alkanes addition reaction I have already discussed in before. Substitution reaction है here one atom or group of atoms replacing one atom or group of atoms. It means the replacing. Substituting kada. So you know in the mathematics cx plus 2x plus 4x plus 5. So x is equals to 2 क्या है? 2 plus 2x plus 4 2 plus 5. It means you are substituting 2 in the x. So it's like that in a substitution reaction we can substitute in a way. So these are called paraffins because these are weak. Paraffins nothing but parameter little, affins and affinity. It's a little affinity. Bond got a very weak bond. And next, very small topic was left. Okay, go fast. Some important carbon compounds. It's mean the summary. Ethanol, ethanoic acid, it's mean CH3COOH. I have discussed acetic acid. Ethanol, ethyl alcohol. Ethanol is prepared on large scale from ethane by the addition of water vapor or in the presence of catalysts like P2O for tungsten oxide at high pressure and temperature. We can also produce ethanol by wheat, barley and gradual fermentation. Today this is the topic what you have understand by this paragraph. Comment me. Anna guys, so once look this and take screenshot and after you can comment me. Okay. Properties. So it is colorless liquid but it has sweet odor. It's mean esters. esters. It is the colorless liquid and it will give sweet odor. Boiling point क्या है? 7. Oh sorry guys. Ethanoic acid. Ethanoic acid properties. So it's colorless and a sweet odor. Boiling point 78.3 degrees Celsius. Pure alcohol is called a absolute alcohol. It is a very important bit, 1 mark. So next, and mixing of some impurities are called the denatural. If a person took 200 ml of denatural alcohol, it becomes toxic and may lead to the death also. So it's very, very, very consumption to health. And if a person, if you mix 10% ethanol in the gasoline, it becomes gasohol. Gasoline plus ethanol. See, gas. So in here all. So combining these both words, we can get the gasohol. Like that only chemistry names will be get. And gasohol is a good motor fuel, and it is also called alcohol. If we took some amount, we feel drunkenness. It is also used in medicines like tincture, cough strips, many toxics. And guys, ethanoic acid, acetic acid, yeah, CH3, COOH. It has unpleasant odor. It is a weak acid. While we add it in a 5 to 8 solutions of water and it becomes into vinegar. Vinegar, it's present acetic acid. So same. CH3COOH. Vinegar. Food preservative. And it is used in presence of pickles. And guys, so this is the ethanoic acid equation. pKa is equals to minus log 10 Ka. Yeah. So the given pKa value, the stronger to the acid. If we mix a small amount of a soap in water, then it is true solution. If we mix more amount of soap in the water, it is colloidal solution, critical micelle concentration. So it's come under saponification. Yeah, saponification. It is very important. You need to study. And next, nomenclature of aliphatic hydrocarbons. I already told aromatic it's nothing but the mate closer chains. If aliphatic, it is not closer, so it's called the single chains. Means it is saturated hydrocarbons. So it means IUPAC, International Union of Pure and Applicable Chemistry. So guys, it is very, very important in very such competitive exams or your subject exam. So see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have told me teeth, probe, bute, pendex, septoctone, tech. Yeah. Saponification reaction, see palmitic acid, stearic acid, oleic acid. So we can see in this food particles also, in soap particles also. It is very common to see. See how many carbons, how many hydrogens, and how many oxides. So it means the structures are very critical to the scientists to know. And soap kya secret formula comes from the foreign countries. This one. Nana, it's very, very, very important. R is equals to C15, H13, or C17, H35, etc. And soap is a sodium or potassium salt of a higher fatty acids. So soap also consists of the more fat. And glycerol. Fats are esters of higher fatty acids and the trihydrogenol alcohol known as glycerol. Glycerol also we will use in the powders, makeup, everything. Yeah, it is prepared from plastic stuff, but so many members don't know it and uses it. Alkaline hydrolysis of esters of high fatty acids producing soaps is called saponification. A true solution is that in which the solute particles dispersed in the solvent are less than 1 nanometer in diameter. So a colloidal solution contains the solute known as disperse, the solvent known as the dispersion medium. So solute, solvent, and solution. Solute is nothing but see glass of water. It's water. We are wearing the salt which is dissolved in it. Salt. So it is dissolved in it. So it is called the solute. So in which you are wearing the salt, in which you are wearing water. So water is a solvent. So when both mixed and you form a salt water. Salt water. So it is called the solution. Okay guys. So it is the difference between the solute, solvent and solution. So here they have solute known as dispersity, solvent known as the dispersion medium. So that's it. Today class was over, guys. I think so you have discussed a lot about the carbon and its compounds, and you know about the holy synapses, and you have understood the topic very clear. I think so I make your topic so clear. So please subscribe to my chemistry life channel, and I will come with the next topic in a very interesting topic with another video. Until then, bye bye. Have a nice day.